Good morning all. Here's a KEB F5 and it is model number 10F5C3B-ZA00. And the complaint is that it's tripping the circuit breaker. So we're going to go here on the terminal board where the line and the motor connect, and we're going to look for short circuits. We have bus plus and bus ground on these two terminals. Here's L1, L2, and L3. Here is PB, U, V, W. So let's see what we get. Let's take and put our black lead on bus plus and our red lead on L1. That's open. That's not a good sign. Here's L2. That is shorted. We have 0-volt diode drop there on L2 to bus plus. Here's L3. We have a diode drop of 0.528. Let's put our red lead on bus ground. There's L1 to bus ground. L1 with the black lead. We have 0.528. Here's L2. See how that drifts up? That's not good. It should go straight to a diode drop. But we have 0.478 volt diode drop there. Here's L3. 0.528. So we have a short circuit on the line side. Let's check the motor side. Let's go black lead to bus plus. Here's U, 0.418. V, 0.420. W, 0.420. Red lead on bus ground. Black lead on U, 0.399. V, 0.401 volt diode drop, and W with the black lead, 0.398 volt diode drop. Let's go in and see if we can fix that short circuit. Well, outright I don't see a three-phase bridge, so it must be part of the IGBT power module. Have the three-phase bridge and UV and W inside the same package. Okay, well, let's make a little bit more room. We'll go deeper inside. See, I don't know if these caps have give up the ghost or if that's just cosmetic damage. Let's see if we can unplug these capacitors. And it looks like they just plug right in. Not sure which way they go to come off. Let's see if we can go this way. There we go. There we go. Won't fit. Get in there. Well, didn't leave you much room to undo those IGBT screws. Let's see. There we go. All right, is that everybody? Something else is holding us up. Come here, flashlight. Oh, it's one of those plastic standoffs. Gotta squeeze the plastic standoff. Release it. There we go. We're free. See if we can see a part number. It looks like VIN 2321. And underneath that it says P086A2209. And underneath that it says 34861 space 0368. Let's go see if we can find a part number for that power module. Now, we're going to have to order it because I don't have that part. And when we order order it and get a new one in, we shall replace this one and hopefully bring this drive back to life. I'm going to replace these electrolytic capacitors. I won't do that right now. We'll have to get the part IGBT 3-phase bridge power module in. I don't want to go any farther because if we can't get this power module, there's no use to do any other kind of work on this power board. So when we get that power module in, we'll swap it out and replace these capacitors. Here I've removed the bad IGBT. I put an X on it so I wouldn't get it confused with the good IGBT. Wouldn't want to solder the bad one back. So I put an X on there. Now, I have it, the new IGBT kind of bolted down. We'll see if I can just slip this on top here. I'm going to have to straighten out a few pins. Let me get my close-up glasses on here. Let's see. Let's see here, come on. Let me get my flashlight, make sure we're getting all lined up here. Pretty close. Everybody is lined up, it looks like, except for this one here in the corner. Let's straighten that one out a little bit. I got this IGBT from a bad drive, so it's not brand new. It's new to this drive, but not new to the KEB world. Here, I'll tell you what, let me get some of that solder out of that hole. I think that's why it's not going in. This one too. That should do it. There we go. Are we all the way down? I think we're all the way down. You want to get the power board tightened all the way down, as well as the IGBT 3-phase bridge power module, before you solder those solder leads to the power board. All the way down, and that way your board don't buckle or bow. Make sure we're all flush. All looks good. This right here is probably the tedious part because you don't want to melt these plastic pieces that are really close to these solder points. Get turned around here. I'll come in from this side. Take my hat off so it don't get in the way. For some reason, solder on this board doesn't want to flow very easily. I had the same problem when I was removing the solder from the bad IGBT three-phase bridge rectifier power module. Solder didn't want to come undone. Something peculiar about this board and solder. There we go. The new used good IGBT is installed. Now we have to do something about this right here. These capacitors, you can see that they're blowed out between the capacitor and the board. We're going to have to do something about that. First thing, I'm going to have to get these capacitors off the board and see what damage to that board has been done. Now, the only capacitor that looks like it may have survived was this middle one. Alright, we'll save that for tomorrow. Let's see how our IGBT diode drops. Got our meter set to diode test mode. let's see, this here is line bus ground. 0.491. That was L1. This is L2. 0.485. This is L3. 0.492. And I think this is motor bus ground. Here's U with the black lead. 0.441. V, 0.441, and W, 0.441. So far, so good. Now, here's the red lead on L1, 0.508, L2, 0.520, and 0.508. On L3, that was L1, L2, and L3. And I think this is motor. There we go. There's plus bus on the motor side. That's U, 0.441. V, 0.440 with the red lead. 0.441 volt diode drop on W. There we go. That's a good IGBT. No short circuits anymore. We just have to fix up this bus capacitor board. This right here is where the bus plus and the bus ground on the line side are connected to the motor side with these pins right here. That plugs in right there. I'm not sure which went bad first. The bus capacitors, and they took out the three-phase bridge because they were bad, or did a surge come through and wipe out the three-phase bridge and the bus capacitors? Which came first, the chicken or the egg? In that case, which failed first? The bus capacitors or the three-phase bridge? You know, when bus capacitors fail and they short, they pull too much current through the three-phase bridge and wipe it out. Okay, we're done for this Saturday. Let's head to the hooch, and we'll finish up this chore tomorrow. All right, all, here we are, day 2. Now we're going to remove these capacitors from the board. These two outside ones look damaged. I'm going to take this one off the board here and see what it looks like. It don't look damaged, this one in the middle, but I'm going to take it off the board anyways. Maybe add a little bit of solder here. Adding solder helps the old solder to flow. this one here, if I heat up this one side, come here, solder, come here, where you at? Let's try to wick out that extra solder right there. Heat up this one lead and that capacitor should come right off the board. There we go. Yeah, you can see there's some explosion damage right there. Let's see what the board looks like. Oh, yeah, that's pretty bad. We're going to have to repair that board before we can use it again. Okay, there's pieces of the label. Okay, this drive took a hit, didn't it? This right here might turn into a 3-day repair instead of a 2-day repair. You know, we've seen worse. We have seen worse, that's for sure. Okay. Yep. That side exploded. Whew, look at the damage there. Let's see what the board looks like. Oh, that board also looks horrible. So we got explosion damage here, explosion damage there. Let's see if we can get that center capacitor off the board. Now it may have survived. I don't know how, but maybe it's on a different circuit from the other two capacitors. Alright. Doesn't look too bad on this side. Let's see what the board looks like. Oh yeah, you can see where it arced out. So all three capacitors took a hit. Whew. I don't know if I'm going to be able to repair that board. I'll go into the North 40 and see if I can find a replacement board on another blown up drive. This one's in pretty bad shape. Alright. Day 2 is looking pretty rough. That's the problems when you're working with voltages. They're a little bit higher than plus or minus 15 or 5. Okay, I'm going to go wander around in the North 40, go through the junk pile and see what I can find. Wish me luck. Well, no luck today. I could not find another board like this in the North 40. So we're going to have to make do with what we've got. Let's go ahead and try and clean up the burnt areas of the board. after we get the board cleaned up, we'll see what we got left. Get me a tub of warm soapy water and put this board down in it. Get some of that conformal coating off. Looks better. Looks better. Now you're probably wondering why I'm going through so much trouble to bring this drive back to life. Can't you get another one? Nope. No, this drive does not exist on the internet. Sometimes you're forced to do what you got to do because there's no replacement. Not that we can find right offhand. Now maybe in a week or two, one of these will pop up on the internet. Maybe. But right now, we got a machine to get going. And it ain't going without this drive. Let that soak for a little bit. All right, put your safety glasses on. Don't want to damage your eyes. All right, are we in the frame? Let's get turned around this way. We're going to work on that one first. Here are 3 good capacitors that we're going to install on the capacitor board. This one is 470 microfarad at 400 volts. These 2 are. This one is 220 microfarad at 420 volts. Now you can see that these 2 terminals, this one over here is not connected, but these 2 terminals are bus plus and bus ground. The nice thing about these capacitors is they're keyed, so they only go on one way. They won't fit onto the board any other way, so I can't get that bus plus and bus ground backwards on the board or not connected. It's only goes on one way. It's a little bit confusing. There's a diagram here on the side that shows pin 1 is the positive of the capacitor. The circle with no number in it is the negative terminal, and pin 2 is NC, no connection. Make a little tabletop. There we go. There's the 2 large capacitors. Let's install the smaller capacitor. There we go. I hope that does us. Let's go back together. Let's get that fan wire put underneath there. Okay. Capacitor board. Put our cover on. There we go. Alright, let's put this bracket on. Here. Slides in there like that. Let's put the control board on. There's slots right here for the capacitor board and the control board. Here's the connector for the control board. And shouldn't have any problems getting that connector lined up if you have the control board in the slots. Okay, let's install the control panel. We'll be ready to power this thing up. Down here I want to jump out the T1 and T2 terminals. That's your motor thermal. Now, the moment of truth. This drive requires, according to the data plate, AC input 200 to 230 volts AC. Okay, we're going to apply that to L1, L2, and L3. This is the part that always bothers me. Will it survive, or did we waste 2 days worth of work? Okay, let me go get the power cord and we'll hook that up. L1. L2. L3. We're going to cover up our drive just in case things go badly. Alright, let's get plugged into the wall. We got to do it. Okay. Get plugged into the wall. Turned on. Here we go. I hear a cooling fan. I can't look. I heard the pre-charge relay energized. We have the bus LED on. The 7-segment display says NOP. No op. I think we got it. Oh, that's the part that always scares me. I don't like to be around these things when they go bang. Whew. Okay. Let's get the camera closer to that and you can see the display. Looks like we got it. We'll put the Fluke oscilloscope on U, V, and W. Look at the waveforms. And then we'll put a motor on it if all looks good. There's U to V. There's U to W. And here's V to W. They all look good. Spread that time out a little bit and you can see the pulse width modulation. Time to put a motor on it. All right, cross your fingers. We're moving. All right, let's talk about the hookups to make that KEB F5 run. Now here we have analog input plus, that's analog 1 plus, analog 1 minus. Whenever you see a plus and a minus, these inputs here are going into an operational amplifier. This would be the inverting input, and this would be the non-inverting input. Down here, the drive itself provides plus 10 volts DC and common for the potentiometer. And I'm using a 10 kilo ohm potentiometer for the wiper connected to analog 1 plus. The common is connected to analog 1 minus. The potentiometer wings are connected to the 10 volts and the common, and the wiper going up here to analog 1 plus. Down here on terminal 14 and 15, 14 is forward, that's the terminal that I used, and 15 is reversed. So that's your forward direction, run forward, and 15 is run reverse. The control release is on terminal 16, and I connect that to plus 24 volts DC supplied by the drive on terminal 20. When we close this switch right here, terminal 14 is connected to plus 24 volts DC on terminal 20. Over here are the line connections. You have L1, N/L2, and L3. Now this particular drive, according to the data plate, required 200 to 230 volts AC, either single phase on L1 and N, or three phase on L1, L2, and L3. Be very careful. A lot of these drives you will see require 400 to 480. And if you put 400 to 480 on a 200 to 230 volt AC drive, it will destroy itself. It will come undone because those bus capacitors are not rated, and that IGBT three-phase bridge is not rated for the higher voltage. So always obey your data plate. You absolutely cannot apply 400 to 480 on this 200 to 230 volt drive. You can't do it. So look at your data plate, and whatever voltage is required by that data plate, that's the voltage that you put on that drive. Here, plus plus and minus minus, that's your plus bus terminal and your bus ground terminal. You saw in the video where we were able to check in diode test mode whether these L1, L2, and L3 were shorted or open, and U, V, and W when we put our black lead on bus plus and our red lead on bus ground. Down here, I used a bow door 1.5 horsepower motor on the U, V, and W. That's a squirrel cage induction motor. And lastly, the T1 and T2 terminals. This is for your motor thermal switch connected to T1 and T2, and I just jumped that out with a piece of jumper wire. Well, there you go. Wasn't that fun? That was a fascinating repair. Very difficult repair. It took a couple of 3 days for us to get through that. But we did it. Good job, folks. Good job. Y'all did a fine job. Now you'll see that I don't have all of these connections used. Only use what you need. And I'll put some diagrams up from the manual that explain what these other connections are. Good job again, folks. Y'all did good.